formula here. So you could do completing the square if you wanted to, but I'm just going to go ahead and do quadratic formula. So show us, how many answers should we have here? 2, right? Okay. So if I do quadratic formula, I'm going to do opposite of b. So I'm going to do 8 plus or minus square root. Let's see, b squared would be negative 8 squared minus 4 times a is 1, c is 9. Everybody over 2a, so 2 times 1. Okay, this is not factorable, so I should not get a perfect square under the square root when I do this. If you do negative 8 squared, you should always make that positive. If I'm being honest with you, whenever I do the quadratic formula, if that number is negative, I don't even put it in as a negative just so I don't make a mistake, because squaring that should make it positive. But you're going to get 64 minus 4 times 1 times 9 would be 36. So we're going to get 28. Everybody over 2. Okay, could anybody raise your hand and tell me, how would you rewrite the square root of 28 so it was in simplest radical form? Like if we used a factor tree or something like that. 2 roots of 7. Okay, so I'd have 8 plus or minus 2 roots of 7. Everybody over 2. Okay, could I simplify what I have there with the radical and the 8? Okay, what would you write down? Perfect. 4 plus or minus. Okay, so all 3 of these, and you don't have to do this on your paper. I'm just going to highlight it on my. Don't ever touch the radical. Don't even look at that once you've got it simplified. If all 3 of those numbers are divisible by the same thing, which they are divisible by 2, you are allowed to reduce it. If one of them is not, then just leave it how it is. But you guys can see, and I'm supposed to get 2 answers, right? So my 2 answers, 4 plus the square root of 7, 4 minus the square root of 7, that plus and minus symbol really indicates a shorthand way of writing those 2 answers. If we were to look at this on the graph, these are kind of garbagey numbers because they're going to involve a radical, but it would cross the x-axis in 2 places, real answers, because I don't have any i's here. But these are called irrational because they have a radical in them. Okay, so just let me show you this just real quick on my calculator. All right, so anytime you take a square root, like this says square root of 7, if you take a square root of a number that's not a perfect square, it will be some garbage decimal that you cannot write as a fraction. Like if I try to do my math, enter, and convert that, it can't. It will just leave it as a decimal. So that's considered an irrational number. It cannot be written as a fraction. A rational number can be written as a fraction. So anything that involves a square root that's not a perfect square is going to be what we call an irrational number, and that's what we're going to work with today. Okay, so in general, I'm just going to give you a little formula for this. These are conjugates that we just looked at. They're exactly the same, but one's a plus and one's a minus. So we've talked about conjugates a little bit. Irrational conjugates, just in general, it's of the form a plus radical b and a minus radical b. That plus and minus symbol for the quadratic formula just gives you those 2 separate answers. We just write them as one because we're using that plus and minus as a shorthand. But what we're going to talk about today is the irrational root theorem, and that's going to say if a plus radical b is a root, 0, answer, whatever, of a polynomial, then automatically its conjugate, a minus radical b, is also. So if you have one, automatically you'll have the other. These always come in pairs because you'd have a plus or minus if we actually went through and did the quadratic formula on it. So anytime one is an answer, automatically its conjugate is also. So you'll just see a couple questions like this on the homework that literally just say, here's a root of your polynomial, tell me, and forgive, this should say find any additional roots, because some of these don't have 2 additional roots. But literally all you have to do is just change up the sign in the middle if you have a square root. So this says 2 minus root 5, so automatically it's conjugate, which would be 2 plus the square root of 5. We're only going to do that if we have a radical. You're not going to do this with anything else. square root of 7, if that's an answer, then automatically, I started to write an x, sorry, negative square root of 7 would be an answer. And just as a little remember from last week maybe, in a factored form, that would look like x squared minus 7. Like I'd add 7, take the square root of both sides, so you'd get plus or minus square root of 7. That would be what the factor would look like if that was one of my zeros. Now, these always trip people up. If it starts with a negative, like this is negative 3 plus the square root of 11, you do not change the sign in front. You only change the sign in the middle to get the conjugate. Like if we had done the quadratic formula on that, it'd be negative 3 plus or minus square root of 11. We wouldn't change the negative out in front. That would remain the same. You just change the symbol in the middle to write the conjugate. Negative root 29, then positive root 29. That would, I could write a factor for this. I'm going to show you how to write the factors for these other ones in a second. They're a little more complicated. This would be x squared minus 29 would be the factor, because you get a plus minus square root of 29.
You have to write plus 29?
If I did plus, then we'd have an imaginary answer. Does that make sense? Because then you'd subtract it. We're going to work on that tomorrow. But yeah, it would have to be a minus here in each of these cases because we get a real answer. It's just going to be irrational. It's going to have a radical. We're not going to have any i's in any of the problems today. Okay. Now, I literally just have the number 16. Okay. Don't write negative 16. That is not going to be, all right, so if it's just an integer, like a negative number or a positive number, no radical, you do not have a conjugate of a plain number. So if 16 is an answer, fine, but that does not mean negative 16 is an answer. So just keep that in mind. So just plain 16. The only additional root you would have here would be the conjugate of this 4 minus root 2. It would be 4 plus root 2. It has to involve a radical to have a conjugate for these questions we're going to do today. The questions tomorrow, it's going to have to involve a term with an I in it. So with it, no I, no radical, no conjugate, okay? Now, we're just going to practice this real quick, write these in factored form. So a couple of the questions are going to ask you just for factored form, so not standard form, just factored form. Okay, so this says write the polynomial function in standard form. And I just said we're going to write it in factored form. We're going to write it in factored form first, forgive me, with the given roots. So if 9 is an answer, what would be like a little set of parentheses for 9 being an answer to my polynomial? Exactly, x minus 9. Okay, now if negative radical 3 is an answer, automatically it has a conjugate. So if you got a radical or an I involved, you better be writing the conjugate if they don't give it to you in the directions. So also positive square root of 3. Okay, now if I wrote that, and I'm going to show you this in a second, this would be x, if I do the negative root of 3, in the factored form it'd be x plus the square root of 3. If I do it for the plus square root of 3, it'd be x minus, so it's the opposite when you put it in the radical form. Now, just in the last question, I just kind of cheated and did this. Like, if I put these together, I know that's going to be x squared minus 3. I just know that. Now, I'm going to show you why, because if that makes sense to you, if you understand that, you could just go ahead straight and write that. This is the factored form. I'm going to show you how to get standard form. And if you want to go right to making this into this, that's fine, if that makes sense to you. If not, let me just show you where it comes from. Anytime you have conjugates and you have them in factored form like this, multiply those together first, and all the irrational or all the radicals should cancel out. So if I just do a quick FOIL on this, I'd have x squared, or you could draw a box too if you want. Now, x times the negative square root of 3. You would just write negative, you put the x out in front, and then the radical 3. We don't put the x afterward because sometimes that'll confuse people as to whether the x is underneath the radical or not, so you would write it out in front. Then I'm going to do radical 3 times x. That would become positive x times the square root of 3. And then these two terms, one's positive, one's negative, they will cancel each other out, so we won't have those. The term on the end, just be careful, this should always be negative because you have a positive square root of 3 times a negative square root of 3. That would be a negative. 3 times 3 under the square root, you can always multiply square roots. You just multiply the numbers together underneath will give you 9. That'll give you a perfect square. All right, so here I've got x squared minus the square root of 9, which is x squared minus 3, which is what I was mentioning to you right here. So if you understand that, you can skip that step if you don't want to FOIL all that out. If you understand that, go ahead and write that factor. I do have to do one more step though, because they also told us that 9 was an answer. So I got to FOIL that with the x minus 9 because I haven't done that yet. All right, now, anyway, if you want to draw yourself a box, or I'm just going to FOIL here real quick. So x times x squared give you x cubed. X times negative 3 will give you negative 3x. Negative 9 times x squared is negative 9x squared. And negative 9 times negative 3 is going to be positive 27. Now, not always, but sometimes if you're multiplying these out, the result might not automatically be in standard form. So just check that real quick. This, I'd have to switch the negative 9x squared and the negative 3x to put it in standard form. Standard form just means your powers of x go down in order from greatest to least. So this is my polynomial function that has 9 as a 0 and then also plus or minus the square root of 3. So we're working backwards from what we were doing in our last couple of lessons. I'm giving you the answer and you're going to write me the polynomial instead of me giving you the polynomial and you trying to find the answers. Is anybody having a question? Okay. I will not lie to you. These are a little trickier, but it's just algebra that you're going to do. Okay, it's a little trickier if you got 2 parts to your root or your 0. So this says write the polynomial function in standard form with the given root. I'm going to start with factored form, and it tells me 5 plus radical 6. So if I have a radical or an I, automatically I have its conjugate, even though they don't write it here. So automatically 5 minus the square root of 6 also has to be one of our answers. All right, garbage number, but that's just how it is for this question. Now, each one of these, whenever you guys do this, I promise this will work every time. When we set up a factor, like if we had 9 on the front, so we said x minus 9. All right, so when you write the factor here, it will work every time, I swear to you. Just do x minus, and then what you have to do here is take whatever the 0 is or the root that they give you, just put it in parentheses if it has 2 parts. So I'm just going to start with the one that was listed in the problem. This would be 5 plus radical 6, and I swear just every time it should just be x minus, and then I'm going to put in the conjugate, which would be 5 minus the square root of 6. It does not matter the order that you write them in, but it should always be x minus. Okay, the deal is, if you wanted to check, if I took 5 plus radical 6, if I plug that in for x right here in the first set of parentheses, I'd have 5 plus radical 6 minus 5 plus radical 6. That would make that 0. Same thing here. If I put 5 minus radical 6 in for this x, we'd have 5 minus radical 6 minus 5 radical 6 would become 0. So it's just minus every time. Now, yes, we are going to multiply this. I know you're excited. Said no one in this room except me. But before you do that, before you do that, get rid of this extra set of parentheses just real quick. Just distribute that subtraction symbol like a -1. And so I'm going to write x minus 5 minus root 6. And then the other one will also be x minus 5 again, but then it'll be plus root 6. Okay, now this is completely up to you. This is my damage, but I always do a box for these, and I will show you why in a second. So I'm just going to draw myself a little 3x3 box. It just helps me organize the information a little bit better, and it also helps me cheat a little bit, and I will explain that to you in a second. I'm going to grab my highlighter, and I can tell you without even doing this problem that these boxes are going to cancel each other out. All right, I'll show you, I'll go ahead and multiply it out, but I can tell you, I didn't even write anything on there. I can tell you those boxes, those 4 boxes are gonna cancel each other out. So I just leave them blank when I do these problems, if I'm being totally honest with you, which you are welcome to do if you understand this. Okay, either one of these factors, just put 1 across the top. So I'm gonna do x minus 5 minus root 6 across the top. And 1 down the side, I'm gonna do x minus 5 plus root 6 across the bottom, or across the left side there. Okay, now just multiplying together here. So x times x give me x squared. X times negative 5 is going to give me negative 5x. And I'm going to go ahead and do this in this problem, but I promise you this is going to cancel out. X times negative radical 6, I would just write that as negative x radical 6. But this is going to go away. Any irrational part, so anything that involves a square root is going to go away. Now, here, x times negative 5x is another negative 5x. These two terms will be identical. They do not cancel each other out, though, because they're both negative 5. So they're going to become negative 10x when we combine like terms. In the middle here, you're going to have negative 5 times negative 5, so you get 25. That does not cancel. All right, now, negative 5, negative root 6 is going to turn into positive 5, negative times a negative, times the square root of 6. That's going to cancel. Down here, x times the square root of 6 is x times the square root of 6. These two boxes cancel each other out. This is positive x radical 6, this is negative x radical 6, so those will not be part of my answer. Right here, if I do square root of 6 times negative 5 roots of 6, these two, one's positive, one's negative, so these two cancel each other out. So normally, like I said, when I do this problem, I just don't even do that, mostly because I'm lazy and I'm smart. So, oh, that was a little high and mighty, sorry. But these cancel each other out. And I just noticed in a pattern there. And it'll always be these two boxes here, these two boxes here. Now, down in the corner, this is a little tricky. You have a negative radical 6 times a positive radical 6. So this will always have a negative in front of it. One's plus and one's minus. Take 6 times 6, that's 36. That will, if they're conjugates, that will create a perfect square right there. So it will always be negative, though, because you're going to have a negative in front of that. So this is going to be negative 6. I'm going to put that together with the 25. Okay, now here's my answer. I'm just going to combine like terms from my box. All the imaginary garbage cancels, or not the irrational garbage, I mean, cancels out, so I don't have to worry about that. The biggest mistake I see people make, this negative 5 and negative 5, those do not cancel each other out. So you have x squared minus 5 minus 10 x's, and then 25 minus 6 would give you 19. So this is going to be my polynomial. Okay. Now, you absolutely don't have to do this, but I'm just going to show you this real quick. So these were my two answers, right? These are my two answers. I'm going to just do the quadratic formula on this real quick and show you that those are my two answers. So here's my polynomial. These were the two answers. If I do the quadratic formula on this, I'd get positive 10 plus or minus square root negative 10 squared 4 times 1 times 19. Everybody over 2a. You guys don't have to do this on these problems at all on the homework. I'm just going to try to show you where it comes from. This becomes, let's see, 10 squared is 100 minus 4 times 19. Fail. All right, this is 24 under the square root. 2. Okay, now I'm trying to put it on here so you guys can see this. 24 would break down into 4 and 6, so it'd be 10 plus or minus 2 roots of 6, everybody over 2. And here are my answers, right? 5 plus radical 6, 5 minus radical 6. As long as all three of these, don't touch the radical, are divisible by the same thing, you're allowed to reduce that. Guess what? That 10 is going to turn into a 5. 2 divided by 2 is 1, and I get 5 plus or minus the square root of 6. That is exactly what we started out with in the problem. Okay? Is anybody having a question about, you don't have to do the quadratic formula part. This is the answer to the question, the x squared minus 10x plus 19. I'm just showing you why it works. Is anybody having a question? Okay, and then just really quickly, because I'm super extra, I graphed this on Desmos, actually, so I could show it to you. But anyway, I just typed in, I had x squared minus 10x plus 19, right? And you guys saw those answers. They're going to be decimals on Desmos, but if you want to check them, if I do 5 plus the square root of 6, that gives me this 7.449 that they got on the graph. 5 minus the square root of 6 gives me this 2.551. So if you wanted to check on Desmos, you could graph it if you wanted to look at that just to make sure. You don't have to. I'm just being extra today, and it's not abnormal for me. So anyway, all right, now I'm going to do one more. Don't get angry with me. This one's harder. All right, so this one's just going to have an added 0 to it. So -8. Do not write the conjugate. Don't write 8. If -8's an answer, cool. That doesn't mean the 8 is an answer. All right, just don't write conjugates if it doesn't have a radical or it doesn't have an I. So that would just correspond to x plus 8, right? Done. Now, with this, if you have a radical, its conjugate is automatically also an answer. So don't change the -2. It's going to stay -2, but minus radical 13 will also be an answer. Okay, now I promise. Just do x minus. It doesn't matter what this starts with. It doesn't matter if it's a positive or negative. Just do x minus and put in these two irrational numbers. So one is -2 plus square root of 13. Again, x minus. Just do x minus every time, it'll work. And then the other one was -2 minus radical 13. Before you try to FOIL anything, just get rid of the extra set of parentheses that you've got in here. So this is going to be x plus 8, oops, and then it's going to be x minus the negative is going to turn into plus 2, and then negative times that radical 13 is just going to make that negative radical 13. Again, minus the negative, this is going to be a plus 2, but this one is going to be plus radical 13. If you have a couple zeros, like this one had that -8 as well. You can, but let's not. You want to multiply together the terms with the conjugates first. You could FOIL one of those with that x plus 8. I'm going to hardcore judge you because that's going to take you forever and it's going to be super annoying, so don't do that. Put those conjugates together first, then all the radicals will cancel out and you won't have to worry about that. And again, this, if you want to, you don't have to. I thoroughly enjoyed the box for this for purposes of being lazy or smart, whatever you want to call it, because I know those 4 boxes are going to cancel each other out, so I don't even do them. You guys can do them if you want to, but you don't have to, if this is making sense. And I'd be happy to write them out, but I'm not going to on this question. All right, this is going to be x squared, this is going to be 2x, 4. These guys will all cancel out. They'll all have a radical with them, but you'll have one of each and it'll go away.
So, like, no matter what, those will always cancel out?
Yep. I'll show you if you want. So this would be like -x radical 13, but then here I'm going to get positive x radical 13. So those two always cancel each other out. As long as you set it up in this format, it has to be like x and then the plain number and then the radical. And then what you, like right here, I would get -2 roots of 13, but then here, this is +2 roots of 13. So these, here, let me highlight, like these two will cancel each other out, and then this one and this one will cancel each other out. It's just one's a positive and one's a negative of exactly the same term. Now, don't forget the bottom corner, that does not cancel out. Negative root 13 times root 13 is going to have a negative in front of it. 13 times 13, 169. That'll always become a perfect square. This box in the corner then is just -13. Okay, so all FOILed together, that's just going to give you a quadratic, right? Because it's just 2 zeros. And I'm going to write it underneath here. It'd be x squared. 2x and 2x don't cancel each other out. They add up, right? 2 and 2 is going to give me 4 x's. And then the box in the middle is a plain number, and the box in this bottom right corner is a plain number. So 4 plus a -13 or 4 minus 13, this is going to be -9. And if you want to graph that and check, you're going to see that -2 plus root 13, -2 minus root 13, those are the answers. but I'm just gonna bring this guy down. We're not quite done, because it also told us -8 was an answer to this question. So I gotta do another little bit more algebra to get the actual polynomial here. Now, you can draw yourself a box for this if you want, like a 2x2, or 2x3, sorry. I usually just FOIL with this if it doesn't involve the radicals. So this is like FOIL on steroids. So x times all three of these things, you're gonna get x cubed plus 4x squared minus 9x. And then I just line up like terms the best I can. I gotta multiply 8 by all three terms there too. So 8 times x squared, I just write it right underneath any other term with an x squared. 8 times 4x is gonna be 32x, and 8 times -9 is -72. And just combining like terms here, this is gonna be x cubed plus 12x squared. -9 and 32 is gonna give you 23x. And then there's nothing to combine the -72 with. So this would be my polynomial with those zeros. The factored form would be what we started out with, and then what we ended with would be the standard form. And then again, I just did this so you guys could look at it if you wanted to see. I went ahead and I typed that polynomial into Desmos, and here I'm going to stretch this over to the side a little bit. So you can see I've got 3 answers here, right? There's the -8. Now these two are decimals. So one of them, if you remember from the original problem, -2 minus the square root of 13. And so that's going to be this -5 point. You guys, oh my gosh, I'm typing on my calculator and I don't even have it on the screen. Forgive me. Maybe forgive me. I can't even get it on here. All right, sorry. All right, that's that -5 point. That's this one. Now the other one, if I do -2 plus the square root of 13, that's going to give me this other place on the Desmos, the 1.606. They're rounding it a little bit there. You can't see more of the decimal and pull it to the side there. They're irrational numbers, but that's an easy way to check on the graph if you wanted to look at it. Okay, is anybody having a question? Stop.